Hello friends, you are watching Mathematics channel number Collage. Please check playlist of this channel to watch more videos of your interest on mathematics. Thank you. Question 1. Matrix A is given and we have to find its inverse. Matrix A is a diagonal matrix and inverse of matrix A is 1 upon determinant of A into adjoint of A. Matrix A is a diagonal matrix, so its determinant is product of its diagonal elements. So determinant of A is minus 1 into 1 into 1 minus 1. Also, for a diagonal matrix, adjoint A is minors of its respective diagonal elements. So minor of minus 1 is 1 minus 0, 1. Minor of this central one is minus 1, minus 0, minus 1. And minor of this one is minus 1, minus 0, minus 1. Remaining elements being the same. So A inverse will be 1 upon minus 1 adjoint A 1 0 0 0 minus 1 0 0 0 minus 1. A inverse therefore is minus 1 0 0 0 1 0 0 0 1. The correct answer option is D. Question 2. If we carefully observe vector A and vector B, we find that A bar dot B bar is 3 into 1 plus 2 into minus 1 plus minus 1 into 1 is 3 minus 2 minus 1 0. Since A bar dot B bar is 0 implies A bar perpendicular B bar, hence the correct answer option is B. Question 3. We have to evaluate definite integral from minus 1 to 1 mod x upon x dx, x not equal to 0. Since the integral is from minus 1 to 1, we have to split the integral at x equals 0. So we write this integral as integral from minus 1 to 0 mod x upon x dx plus integral from 0 to 1 mod x upon x dx. We name this first integral 1 and this second 2. Integral 1 equals integral from minus 1 to 0, x being negative, mod x will be minus x upon x dx. Integral from minus 1 to 0, minus 1 dx, minus x from minus to 0, 0 minus minus 1, minus 1. Integral 2 equals integral from 0 to 1, x being positive, x upon x dx, integral from 0 to 1, 1 dx, x from 0 to 1, 1 minus 0, 1. Now adding 1 and 2, minus 1 plus 1, 0. Hence, the correct answer option here is B, 0. Question 4. From the 4 options given, we have to choose which of them is not a homogeneous function of x and y. General practice is to put x equals kx and y equals ky in each of these functions and check if they can be written as k times the original function fx. Careful observation and some logical thinking shows that the first 3 options A, B and C are homogeneous functions, but the last is doubtful. So let us check. Tan of kx minus sec of ky cannot be written as k times tan x minus sec y. Hence, tan x minus sec y is not a homogeneous function in x and y. So the correct answer option D. Question 5. This is about a modulus function and about its continuity and differentiability. This being a modulus function is continuous on R, especially fx is continuous at x equals 0 and at x equals 1. Now to check its differentiability, the graph of this function will be mod x and mod x minus 1. The critical points are 0 and 1, and at these critical points there are sharp corners where derivative does not exist because the slopes of the lines emerging from these critical points 0 and 1 are different, one positive and another negative, which tells us fx is not differentiable at x equals 0 and x equals 1. Hence, the correct answer option is C. Fx is continuous but not differentiable at x equals 0 and x equals 1. Question 6. A is a square matrix of order 2 and determinant of A is 4. We have to find value of determinant of 4 adjoint A. Determinant of A is 4. Determinant of adjoint of A is determinant of A power n minus 1, where n is order of the determinant. So here it will be 4 power 2 minus 1, 4. Next we have determinant of 4 adjoint A is 4 square determinant of adjoint A, which is 16 into 4, 64. Hence, the correct answer option B, 64. Question 7. E and F are two independent events, which also means that E and F bar, which is complement of F, are also independent events. And we have for independent events probability of E intersection F bar is PA into PF bar. Now, conditional probability of E provided F bar has occurred will be PE into PF bar upon PF bar. Cancelling PF bar, we get PE, which is given to be 2/3. So the correct answer option here is C, 2 upon 3. Question 8. We have to find absolute maximum value of the function x cube minus 3x plus 2 in closed interval 0 to 2. First, we will find from fx f dash x 3x square minus 3. Next, we find critical points by equating f dash x to 0. So 3x square minus 1 is 0. X square minus 1 is 0. X is plus minus 1. We will take only plus 1 because minus 1 does not lie in this closed interval 0 to 2. Now fx at x equals 1 will be 1 cube minus 3 into 1 plus 2, 0. We will evaluate fx at the endpoints also at 0 and at 2. So f0 will be 0 cube minus 3 into 0 plus 2, 2, and fx at x equals 2 cube minus 3 into 2 plus 2, 8 minus 6 plus 2. Out of these three values 0, 2 and 4, largest value 4 will be the absolute maximum value. Hence the correct answer option here is C, 4. Question 9. Three matrices A, B and C are given and we have to select the correct option. Order of matrix A is 3 by 3, that of B 3 by 1 and of C 1 by 3. Matrix multiplication is possible only if number of columns of first matrix is equal to number of rows of the second matrix. According to this rule, matrix multiplication AB, CA and BC is only possible. Only AB is present in option A. Hence, this is correct option. Question number 10. Here, equation in terms of integral is given and we have to find the value of this k. We can solve this integral by substitution method. We will put t equals this 1 upon x and differentiate dt equals minus 1 upon x square dx 1 upon x square dx equals minus dt. So this integral becomes integral for this 1 upon x square dx. We put minus dt and for 2 power 1 upon x we put 2 raised to t minus integral 2 raised to t dt minus 2 raised to t upon ln 2 plus c minus 1 upon ln 2 into 2 power 1 upon x plus c, which is given to be equal to k times 2 power 1 upon x plus c. Comparing the coefficients of 2 power 1 upon x, we get k equals minus 1 upon ln 2. So the correct answer option here is A, minus 1 upon ln 2, or minus 1 upon log 2 to the base e. In this question, a bar plus b bar plus c bar equals 0 given. Mod a bar is root 37, mod b bar 3, and mod c bar 4. We have to find angle between b bar and c bar. From a bar plus b bar plus c bar equals 0, we get a bar equals minus of b bar plus c bar. Mod a bar square will be mod of minus b bar plus c bar whole square. That will be mod b bar plus c bar whole square. Now mod a bar square is mod b bar square plus mod c bar square plus 2 b bar dot c bar. Putting the values, root 37 square 37 equals 3 square 9 plus 4 square 16 plus 2 b bar dot c bar. 2 b bar dot c bar equals 37 minus 25 12. B bar dot c bar equals 6. Now b bar dot c bar is mod b bar into mod c bar cos theta. Theta is angle between b bar and c bar equals 6. 3 into 4 cos theta equals 6. Cos theta is half. Theta is cos inverse half. Theta is pi by 3. So correct answer option C, pi by 3. Question 12. In this question, we have to find the integrating factor of the differential equation. This one. Given differential equation can be written as dy by dx equals 2y upon x plus 2y cube. Here we have to take reciprocal. Dx by dy equals x plus 2y cube upon 2y. Now we can separately divide 1 upon 2y into x plus 2y cube upon 2y y square. This can be written as dx by dy minus 1 upon 2y x equals y square. Here minus 1 upon 2y is py. So integrating factor will be e power integral py dy, that is minus half 1 upon y dy, e power minus half ln y, e power ln 1 upon root y, 1 upon root y. So the correct answer option B, 1 upon root y. Question 13. A is given to be a scalar matrix and we have to find y power x. When A is a scalar matrix, all its diagonal elements equal, which means this y is 7 and its non-diagonal elements are equal and 0, which means this x must be 0. Therefore, y power x will be 7 power 0, 1. Hence, the correct answer option is B, 1. Question 14. Here, the corner points of the feasible region of the LPP are given, objective function is given, and we have to select correct option from the 4 options. This can be answered by looking carefully at the options. Z equals 18x plus 9y will be maximum only with the corner point 40, 15. So the answer will be either C or D, but for minimum value we have to check Z equals 18 into corner points 15, 20 gives 18 into 15 plus 9 into 20, 270 plus 180, 450, and Z equals for the corner point 2, 72 gives 18 into 2 plus 9 into 72, 36 plus 648, 684. 450 is minimum, implies correct answer option is C. Question 15. A and B are invertible matrices. Then we have to tell which of the following options is not correct. That means false or incorrect. Obviously, it is the first option A, not correct, because if A plus B is submatrix C, then it is not necessary that its inverse will be equal to sum of B inverse and A inverse. It could be different, whereas rest of the options B, C and D are correct. Question 16. The feasible region of a linear programming problem with objective function given is bounded. Then we have to tell which of the following is correct. When the feasible region of a LPP is bounded by rule, by theorem, it will have maximum and minimum values. Therefore, rest of the options A, B and C are incorrect. Question 17. We have to find area of the shaded region bounded by the curve y square equals x, line x equals 4 and the x-axis. This rightward opening parabola has equation y square equals x, y equals root x, and the line x equals 4 is this one, and the area we have to find is this one. Area of shaded region is given by integral y dx from 0 to 4 here, which is integral from 0 to 4 of root x dx. Hence the correct answer option is this D. Question 18. The graph of trigonometric function is shown here. We have to tell which of them represents graph of its inverse. This given graph is of y equals cos x. Graph of its inverse can be obtained by interchanging x and y axis. So in the option, this x axis is replaced by y axis and this y axis is replaced by x axis in this option C, and only a principal value branch, this one, has been shown in its inverse. So C is the correct option. Here function given is y equals 3x minus 5, 3x equals y plus 5, x equals y plus 5 upon 3. Now here, if fa equals fb, then 2a minus 5 equals 2b minus 5, which implies a equals b. This shows distinct inputs always produce distinct outputs, which implies this function is injective, that is 1 1. If we express x in terms of y here, for integer y equals 1, we get x equals 6 upon 3 2, which is also an integer. But if we take y equals 2 being an integer, we get x equals 7 upon 3, which is not an integer, implying it is not surjective, that is onto. Therefore, this is not a bijective. So assertion A is wrong. Now talking about reason, a function is bijective if it is both surjective and injective, which is true. That means which is both injective means 1 1 and surjective onto. So here option C is correct, which says assertion is false but reason is true. Question 20. Again an assertion reason based question. Assertion A says a piecewise function given here is continuous at x equals 5 for k equals 5 by 2, and reason R says for a function f to be continuous at x equals a, left hand limit equals right hand limit equals f of a. We know for sure that reason R is correct. We have to check for assertion A. Here left hand limit as x tends to 5 negative of 3x minus 8, this one is 15 minus 8 7. Right hand limit as x tends to 5 positive of 2k is 2k. Now for this limit to exist, left hand limit should be equal to right hand limit. 2k should be 7, k should be 7 upon 2, but here k is given to be 5 upon 2. Therefore assertion A is false. Hence the correct answer option is D. A is false but R is true. Friends, if you like this video, please like, share and subscribe this channel. Please check playlist of this channel. Perhaps you might find videos of your choice. Thank you.